Okay, so the last type of carbocation rearrangement we're going to see this semester, at least, is a so-called ring expansion. Okay, and so we saw how we could form secondary carbocations, and we'd have either a 1,2 hydride shift or a 1,2 alkyl shift to go to a lower energy state, i.e., a tertiary carbocation. Okay, but now what we're going to see is we're going to see ring expansions. So I'm going to go from a compound that has ring strain. The cyclobutyl group has 90-degree angles, and so we know that we have angle strain in that particular substrate compound. Over here, we're going to go to a 5-membered ring, and we know that cyclopentyl derivatives have practically no strain. Okay, they have a little bit, but not enough to make a huge difference. Okay, and so again, the first thing, of course, we need to do is we need to form a carbocation. All right, and so this is alcohol, so we need to turn OH into a good leaving group. So we're going to protonate it. We're going to form this intermediate species. We're going to lose water here. And then what I'm going to form is I'm going to form a carbocation. And it doesn't even really matter that it's on a secondary carbon. That's kind of irrelevant here. What's important is I'm going to form a carbocation that is a carbocation in a system that has a considerable amount of ring strain. Okay. And so what I'm going to do then is I'm going to open up my ring and kind of like flap it open so that I can alleviate this ring strain. And I'm going to form this 5-membered ring. Now, again, how do you know when to do this and when not to do this? Well, on the exam, it will say, propose a mechanism going from here to here. So I'm going to tell you, hey, you started with this and this is what you made. So you'll know it's a ring expansion because obviously I went from a 4-membered ring to a 5-membered ring. Okay. And so again, you have to be a little bit more detail oriented when you start doing these types of reactions, because it's really easy to lose yourself, lose your carbons, and kind of get overwhelmed with what you're doing. So what I've always told my students to do is to count your carbons. And I'm not counting this for any type of nomenclature. I am just counting them. All right. So here I have my carbons that will be involved in the so-called ring expansion. Okay. I know currently carbons 3, 4, 5, and 6 are making up the 4-membered ring. For me to expand this, okay, it looks like I could easily break the bond between carbons 3 and 6 and shift the electrons over to carbon 2, forming a brand new bond between carbon 6 and 2. Okay. And so again, I'm going to go ahead and I'm going to redraw cyclopentane. I'm not going to redraw. I'm just going to draw cyclopentane. And I'm not going to put anything anywhere until I redraw my carbons. In other words, I renumber my carbons. And again, the reason I do this is because it's very easy to get confused. Now, I'm going to start with the bond that I just made. I just made a bond between carbon 6 and 2. All right, so this right here represents my new bond. And then I'm just going to go ahead and number, and I'm going to go 6. I'm going to go backwards. 6, 5, 4, 3. Now on carbon 3, I had a methyl group. On carbon 2, I also have this methyl group coming off, so I'm going to put that there. So now what I need to say, okay, so if I took the electrons away from carbon 3 and put them between 6 and 2, then what does that leave me on carbon 3 now? Well, now I know because I took these electrons away right here. Carbon 3 now has a carbocation, and the bromide that we formed in the first step, can now come and attack and form that species there. They're not that hard. The hardest part about these is making sure that you number and you number consistently. You number consistently. I've seen students that will just number and then randomly number the second ring. That doesn't do you any good, right? And so the whole reason of numbering is, again, what did I do? Is I knew that I was making a 5-membered ring, right? Because I know that this carbon here, if I count my carbons, 1, 2, 3, 4, 5-membered ring. Okay. I also knew that when I was shifting this bond between 3 and 6 over to make a new bond between 6 and 2, okay, I then went and identified that bond over there, and that's where I started numbering. Okay. Don't number until you have identified your new bond, and then number between, make that bond between the 2 carbons and then number them first. Okay. All right.